Imagine the universe, billions of galaxies, each with billions of stars. Now imagine trying to count them. It's a mind-boggling task. Just like the universe needs order, so does data in the digital realm. That's where algorithms like Heap Sort come in, our cosmic organizers. In this vast cosmic dance of numbers, Heap Sort emerges as a powerful force, bringing order to chaos. It's a sorting algorithm, yes, but also a symphony of logic and efficiency, ensuring every element finds its rightful place. Before we embark on the sorting journey, we must first understand the heap. Imagine a cosmic pyramid of numbers. At the apex, the largest number reigns supreme. Below it, smaller numbers cascade down, forming a hierarchical structure. This, my friends, is the essence of a heap. More formally, a heap is a binary tree-based data structure with a unique property. The value of each node is always greater than or equal to its children, for a max heap. This ensures the largest element always resides at the root, like the king on a cosmic throne. Now let's unravel the magic behind Heap Sort. The first step is to transform our unsorted data into this magnificent cosmic pyramid, the heap. This process, known as Heapify, is like the sorting hat in Harry Potter, carefully assigning each number its designated position in the heap. We start by comparing a parent node with its children. If a child is larger, we swap them, ensuring the parent is always mightier. This comparison cascades down the heap like a cosmic wave, until the largest element ascends to the top, claiming its rightful place as the root. Section 4. The Grand Sorting Ceremony. Extracting order from the heap. With our cosmic pyramid established, the sorting ceremony can begin. We pluck the king, the largest element at the root, and place it at the end of our sorted array. The last element in the heap then ascends to the vacant throne. But wait, the new king might not be the largest. Fear not, for we unleash the Heapify magic once more. The pyramid readjusts, ensuring the largest remaining element ascends to the top. This process repeats, each time extracting the largest element and placing it in the sorted array, until all that remains is a perfectly ordered cosmos. Section 5. Why Heap Sort matters in this vast universe. In this vast digital universe, efficiency is paramount. Heap Sort, with its elegant structure and clever operations, consistently delivers. Unlike some sorting algorithms that crumble under pressure, Heap Sort remains steadfast, guaranteeing a worst-case time complexity of O of n log n. Furthermore, Heap Sort is remarkably memory efficient. It operates directly on the input data, requiring minimal additional storage. This makes it a wise choice for sorting massive datasets like cataloging the stars in our galaxy, without consuming vast cosmic resources. Section 6. Heap. Sort in action, real-world marvels. The applications of Heap Sort extend far beyond the realm of theoretical elegance. Consider the bustling stock market, where real-time data streams constantly fluctuate. Heap Sort efficiently manages priority queues, ensuring the most urgent trades are executed first. In hospitals, Heap Sort helps prioritize patients based on the severity of their conditions, ensuring timely medical attention. From routing data packets on the internet to scheduling tasks in operating systems, Heap Sort quietly powers countless applications, ensuring our digital world runs smoothly and efficiently. Section 7. Conclusion. Embracing the elegance of Heap Sort. As we conclude our cosmic journey through the world of Heap Sort, let us marvel at its inherent elegance. Like a perfectly orchestrated symphony, it combines a simple yet powerful data structure with an efficient sorting algorithm, bringing order to even the most chaotic datasets. Understanding Heap Sort empowers us to tackle complex sorting challenges with grace and efficiency. So embrace the power of the heap, and let it guide you in your own explorations of the digital cosmos.